Here is something that will completely break your sense of scale. You think space is big? The entire observable universe is 93 billion light-years across. And our galaxy, the Milky Way, is just one of 2 trillion galaxies inside it. Now here is the question that keeps physicists up at night. Can we ever leave it? Right now, as you watch this, our fastest spacecraft, Voyager 1, is crawling through the outer edges of our solar system at about 38,000 miles per hour. Impressive, right? At that speed, it would take Voyager approximately 75,000 years just to reach the nearest star, Proxima Centauri. And the Milky Way is 100,000 light-years wide. Do the math. At Voyager speed, crossing our own galaxy would take over 1 billion years. We are not even close to being a galactic civilization yet. But here is where it gets genuinely fascinating. Scientists and physicists are not just dreaming. They are actually working on ideas that could one day make intergalactic travel theoretically possible. The first concept is generation ships. Imagine a spacecraft so massive, so self-sustaining, that entire civilizations live and die on board across thousands of generations. Your great-great-grandchildren, multiplied by 1,000 generations, would be the ones to finally arrive. It is not science fiction. Scientists have seriously modeled this. The ship would need to carry a breeding population of at least 10,000 people, stable food systems, psychological stability protocols, and a civilization that does not forget why it launched in the first place. The challenge is not just engineering. It is human nature. The second concept is something even more mind-bending. Suspended animation, or cryosleep. If we could pause the human body at a cellular level, a journey of millions of years could feel like a single night of sleep. Research into torpor states, where the body drastically slows its metabolism, is already being tested for long-duration space missions by NASA. We are in early stages, but the science is moving. Now here is the part where things get truly wild. Theoretical physics gives us 2 more possibilities that sound completely insane, but are mathematically allowed by our current understanding of the universe. Alcubierre warp drive. In 1994, physicist Miguel Alcubierre proposed a method of travel where spacetime itself bends around a spacecraft. The ship does not actually move through space. The space around it compresses in front and expands behind, effectively surfing a wave of warped spacetime. It would not violate Einstein's laws because technically the ship stays still while space moves. The catch? It requires a form of exotic matter with negative energy density that we have not confirmed exists yet. But in 2024, new theoretical models have revisited this concept and found potential loopholes that reduce the energy requirements dramatically. And then there is the concept that breaks everything. Wormholes. Einstein and Rosen described theoretical tunnels through spacetime back in 1935. A stable traversable wormhole connecting 2 points in the universe, potentially separated by millions of light years, would allow instantaneous travel. The problem is stability. Without exotic matter, wormholes would collapse before anything could pass through. But here is the thing. Science once said we would never land on the moon. It once said the atom could not be split. Now let us zoom out to the biggest obstacle of all. Even if we solve propulsion, even if we cracked warp drives or wormholes, there is something far more terrifying waiting at the edge of our galaxy and beyond. Dark energy. The universe is not just expanding. It is accelerating its expansion. Galaxies beyond a certain distance are already moving away from us faster than light. The Andromeda Galaxy, our nearest large neighbor, is actually approaching us and will merge with the Milky Way in about 4.5 billion years. But beyond the local group, the cosmic web of galaxies is becoming unreachable. Every year that passes, more of the universe crosses the cosmic event horizon and disappears from us forever. So can humans ever leave the Milky Way? Technically, with current physics, no. Not in any human lifetime, not even in the lifetime of our entire civilization as we know it. But with theoretical physics? With technologies we have not invented yet. The answer shifts to a breathtaking maybe. And in science, maybe is the beginning of everything. The real question is not whether the physics allows it. The question is whether humanity will survive long enough and stay curious enough to find out. The universe is not waiting for us. But perhaps one day, we will stop waiting for it too.